Hi everyone, it's Kaswini here again. Um, as usual, I'm here again to take you through what we did last week. This is the week 6 of my training here at Web3Bridge Cohort 7. So, yeah, I normally give you weekly rundown of what we did, and I take out my time to explain things to the best of my knowledge and how better my audience or viewers can understand what we have been doing so far. So this week was this week was pretty awesome and hectic. Yeah, because we wrote our first eviction test and everybody was like on their toes. Everybody was trying to be at their best so that they don't get evicted from the cohort and all of that. So, but before the eviction test, uh, we did other things and all of that. So this week, we learned how to fork a mainnet, like how to fork a mainnet and interact with a mainnet. For instance, let's say uh, we forked Uniswap and we're able to interact with some of the functions in the Uniswap smart contract from our own codes locally. Yes, we also learned how to impersonate an account on the mainnet. Like, let's say you want to perform a swap, you need USDT or ETH. You have to impersonate an account on mainnet that has ETH. You use it to test a function locally to see if it works and all of that. We also uh, learned about what is it called again? We learned about a token swap contract and all of that. So yeah, I also wrote a smart contract. It's taking a smart contract that enables users stake ETH, and after a particular or a stipulated period of time, when they want to withdraw their money, they get their ETH back, and they also receive uh, an APY for staking on the smart contract. So I'll take you through the code and explain how that works so you get to understand. So first of all, this is from what you're seeing on my screen, this is the smart contract, the token smart contract I created. So the way this staking will work is when you stake 100 ether or let's say 20 ether, the smart contract will mint a token for you. So in this case, we are using a degen gas like DEG token. So it means 20 degen gas for you. It means the same amount of the equivalent of the ether you're staking into the contract. It means it for you. So uh, after your staking period have elapsed, when you want to withdraw your ether back with your calculated amount of APY, you have to return that DEG that was minted to you. So if you don't have that DEG, you cannot withdraw your fund. So that DEG token is like a placeholder token that's like a certificate or a receipt issuance that shows that yes, you actually staked this amount of token in our contract and all of that. So and also we interacted with it locally from our script and all of that. So this is the token. So here I imported the degen token and I say contract staking is degen token. So here I created a struct called stake data that holds the amount the user is taking, the number of days the user wants to leave their Ether with us, the number of days the user wants to stake that token, and a year later. Now I'll explain what this year later does. So here I have a mapping of address to this stake data. So this is a unique identifier that it's pointed to this stake data. So any user that stakes, this address holds the user data and all of that. So I also created a state variable called admin. So this will be used to ensure that only admin executes a particular function. So I also wrote this constructor on line 18, which runs once this contract is deployed. So what it does is it sets the person that deploys this contract to the admin of this contract. So this is our staking function. So what it takes in a parameter called days in unit external payable. So that means this function receives ether. With this function, with this payable here means you can send ether to this contract using this function. So first of all, I did a require statement ensuring that the value the person is sending is not less than 0. So require that msg.value is greater than 0, else it will revert and say you can't stake 0 value. Then it also requires that the number of days you want to keep your ether with us is greater than 0. Earlier, I made it to be greater than 7 days. So you must stake, your stake must be above 7 days. But for the purpose of testing, I had to make it to be 0. So staking period can be less than 0 days. So here I had to point to the storage, and I got S data and I set it to stakes pointing to the person calling this function. So that way I'm able to assign that address to this mapping, which is a unique identifier of the stakes. So now I say sdata.amount is equals to plus equal to the msg.value the person is passing. And I now say number of days. So I'm using block timestamp here plus in bracket the days the person passed times 1 day. So this would basically be if the person passed like 7, it would be 7 days because 7 times 1 day is 7 days. So I now used sdata plus yearlater is equals to block.timestamp plus 365 days. So I'll explain why I did this, because if we are using block.timestamp with the days, we definitely need to use block.timestamp with the years too, because if you go down to where we are calculating APY, it's saying days over year later. You understand? So normally it's supposed to be, if maybe it's 7 days, it's supposed to be 7 over 365 days. But if we only used block.timestamp with the days and not with the 365 days as well, here will be like 7, here will be like block.timestamp plus 7 over just 365, which will always return a huge number. So we have to also make sure that we add this to block.timestamp so that everything is even. So once this part is passed, it means okay, in our Degen token we have a min function here. So it calls the min function and pass in the value, the value equivalent of ether you're staking in here. So that means if you're staking 20 ether, it means 20 DEG token for you as well. So over to the withdraw function. The withdraw function, okay, first of all, okay, here, if you notice here, we reference this stake data, reference this storage here because we are writing to storage. That's why we are using storage here. And it's a data type of our user-defined data type, which is a struct of stake data. And we are doing the same thing here, but here, since we are only reading, we are not writing to it, we use memory here. So what we did here is stake data, memory, user stake data, then stakes messages of sender. So we are trying to get the mapping of the messages of sender was stored in this particular address. So now we require that block.timestamp is greater than user stake number of days. So this is where it checks if the number of days this person specified has elapsed, you understand, has passed. Now, this was why we use block.timestamp here, because if we didn't use block.timestamp here plus days, there was no way we could do this check here, you understand, because if you use just 7 days here, block.timestamp would definitely be greater than 7 days and all of that. So that was why we use block.timestamp here. So block.timestamp greater than user stake number of days, right? So now, if this is not true, then it reverts and says staking period not reached. Then we also require that the user staked amount is greater than 0. You can't withdraw what you don't have. So if you have not staked here, you can't withdraw. That's why we have this check here. So, and also we say require that balance of messages.sender is greater than or equal to staked amount. Now, this is where we check to ensure that the token we give to you, you still have it, because balance of is a function in ERC20 standard tokens. So once you do balance of messages or sender, it checks if it checks the balance of the token, the balance of the address of that particular token. So it checks if the balance of that token is greater than or equal to the amount of ETH you stake with us. Else we tell you placeholder token not enough. So if these three guys are passed, then here we get our calculated APY. So this is an internal, a private function that returns the APY of the amount the person staked using the number of days. So days quotient, days over year later, then yield is equal to days quotient times the amount you staked, right? So this was what we did here. According to the question that was given to us, this is the formula they asked us to use. So now this returns your calculated APY. So the amount we are going to transfer to you now is your staked amount plus your calculated APY. Now I know you'll be asking, where does the APY comes from? So the APY comes from basically, if you stake here, we'll use your Ether to do business, do trade, and all of that. So we have to make sure that there's always money in this contract at all time that can pay people back their APY. So here we now say, first of all, we set the stakes, messages.sender, the stake amount to 0. So also we set the stake messages.sender number of days to 0. Then okay, I'm just seeing the bug here. We are also supposed to set the year later to 0 and all of that. So here we now said transfer. So this is where we transfer the token you have, transfer messages.sender address this user stake amount. Okay, this is where we transfer that token you have back to this contract. So we remove the token from your address before we pay you. So payable messages.sender dot transfer transferable. So we send you the money. So this function here shows you the APY, the calculated APY, and this function checks the balance of Ether in this contract and all of that. So this function is supposed to be withdraw from contract. So this is where the only admin comes in. Only admin can withdraw from this contract. This was why we made use of this admin state here and all of this. So this is where only admin can withdraw from this contract. And we also have a fallback function, a receive function, where users can send money to this Ether to this contract and all of that. So this is the contract we wrote, and I also interacted with it. This is the deploy script. I deployed it on Ropsten. Let's see. Let me see this here. So I deployed it on Ropsten and Goeli. It's easier. Goeli is faster than Ropsten, so that's why I later deployed it to Goeli so we can interact with it. This was where we wrote our interaction script. So first of all, after deploying it, we had to interact with it. We connected to, okay, I learned other ways of connecting to your smart contract. At first, you can make use of an interface. This is on line 5, which I commented. Then this is another way to interact with it. Here, you just use ethers.get contract factory, passing the contract name. Then you also use the variable you assigned it to here, dot attach, and passing the contract address. So, and this was where we interacted with it. So at first, I called the stake function here on line 11. So I called .stake. I passed in number of days to be 1, and I passed in a value of 0.5 Ether. So, and here, whenever you're making a write call to the blockchain, you make use of this .wait. So you wait for the transaction to go through. Then I also console logged the logs or the result of whatever came with this call and all of that. So that works. And also here, I also query the contract again to get the contract balance. So let's see this on Goerli. Let's check this on Goerli network. So Goerli. So if you check this on Goerli, I believe that contract should still have my money in there. I've not removed it. So let's see. Yeah, it's still there. Okay, the contract still has 1.5 Ether because I interacted with it twice. So you see, we say 5 days ago. This also 5 days ago. The first one is 1 Ether. The second one is 0.5 Ether, where I was interacted with it, and this was when I created the contract. So, and this is about the staking contract we created. So, in our test, we talked about in our test, sorry, we asked to build an NFT, and we should also use Pinata and IPFS as our decentralized storage platform. So I learned how to use Pinata. We created the smart contract for this is a smart contract for what is it? This is a smart contract for uh, the uh, the NFT. I called it Cast NFT, and I made my max supply to be 5. So it's just a simple contract we use, and we made it of the safe mint. And here I'm passing an address to which it will mint this NFT to, and I passed in a URI as well. So after this, I deployed the contract here. This is why I deploy the contract. So after the deployment, returns the address, and also this is where I interacted with it to mint. So to show you that all this was all successful, uh, this is this is the contract address, the contract address of the NFT, and this was when it was deployed. This was when I did my first mint. Uh, so here I try to sell it on OpenSea testnet, obviously. So this is why you're seeing this set approval for and all of that. This is why I minted another token. So let's move over to OpenSea, and this is the NFT here. This is the beautiful NFT. You can just test and buy it from me. So I think that's basically it. And also yeah, prior to the test, we while we were trying to study and make sure we get ready for the test, I had to interact with chainlink API that returns price feeds of different tokens to USD pair, BTC token to USD pair, and all of that. But I don't want to make this video longer than how it is right now, so I have to stop here for today. I hope I was able to explain better and I was able to do justice to my breakdown. Thank you very much for watching. I remain your guy. Peace out.